We need to know how to use Newton's laws and when which law applies. So if we look at this question, it says that these 5 blocks are attached to one another by 4 strings with negligible masses, and the 50 kilogram mass piece hangs over the edge of a table with its string suspended over a frictionless pulley. So if we look at this question, the kinetic frictional force here is going to be 5 Newton. Let's just make a note of that so we know that friction everywhere has a value of 5 Newton. Now remember, this is a rough surface, and that explains to us that there is a frictional force. All 4 of the blocks on the surface will experience this frictional force. So when we look at this question, the most important part is the fact that the system accelerates to the right. The moment the question mentions acceleration, we need to go and have a look at Newton's second law, where acceleration comes in. You know, Newton's first law says that an object will remain at rest or move at a constant velocity unless a resultant force acts upon it. Newton's second law says when that resultant force acts upon it, the object will move in the direction of the acceleration. The acceleration is directly proportional to the force and inversely proportional to the mass. So when we see acceleration, we immediately know that we are going to use this. F net equals ma. For Newton 1, F net equals ma is actually also 2, but a is 0 because constant velocity means no acceleration. So when we use Newton 1, F net equals 0. When we use Newton 2, F net equals ma. So what we're going to do here is for each one of these blocks, we can go and actually draw a free body diagram. So if we go and we draw a free body diagram for this first block, we know that because it's on a surface, it will experience a normal force, a force of gravity, and now there's also a force of tension. You see it's called T1, and in the opposite direction of motion, a frictional force, Fk. So I'm just going to call it a friction subscript K for kinetic friction. If we look at the second block, we can go and draw a free body diagram, Fn upwards, Fg downwards, and we know that now we have T2 pulling it to the right, but we have T1 pulling it to the left, and then also the force of friction. Remember that when we have a tension force between 2 blocks, the tension that block 1 experiences due to block 2 is equal to the tension that block 2 experiences due to block 1. That's Newton's third law. If we look at the 3 kilogram mass, here we see that we have Fn, Fg. Now we have to the right T3, to the left T2, and then remember that frictional force, kinetic friction. For this block over here, we're going to have Fn and Fg. Remember that when we have a block on a surface, we will always have Fn. Then we have T4, to the right, to the left T3, and then of course our frictional force. Remember that you also have to do a free body diagram for the 50 kilogram block. There will be no Fn here because there's no surface that the block is resting on, so T4 is pulling it upwards, and downwards we will have Fg. So if you go and you calculate Fg for each one of these blocks, remember it's going to be 1 times 9,8 for the first block, 2 times 9,8 for the second block, etc. So for the 50 kilogram block, this is going to be 50 times 9.8, which is going to give you a value of 490 Newton. Now when we look at this, we can go and use F net equals ma and come up with an equation for each one of these blocks. Let's have a look at the first one. So we use F net equals ma, and remember that the vertical forces are balanced. The block is not moving up or down, so we know that we are not going to look at them now. We're going to look at the acceleration in the horizontal. I'm also going to assume that my acceleration to the right is positive. So when I do this now, I'm going to take my force T1 to the right, positive, minus my force of friction, which we already know is 5 Newton, is going to be equal to, and my mass, 1 kilogram times A. So here we can say T1 minus 5 equals 1A, and we can rewrite this as T1 equals 2a plus 5. And that is now our first formula equation that we come up with. Then for the second one, if we once again use F net equals MA, we're going to have T2 minus T1, and now minus our frictional force, which is 5 Newton, equals MA, where the mass is now 2A. So we're going to do T2 minus T1 is equal to 2A plus 5, and that is our second equation. If we use F net equals MA for the third block, we're going to have T3 minus T2 minus the 5 Newton is equal to MA, which is now 3A, and here we say T3 minus T2 is equal to 3A plus 5, and that is our third equation. Using F net equals MA for the last block on the surface, it's going to be T4 minus T3 is going to be subtracted. Also our frictional force is going to be equal to 5A. So here we say T4 minus T3 is equal to 5A plus 5. And that's our fourth equation. And now I'm just going to move up a little bit so we can do this last one. Here, remember the block, because it's accelerating and is not on the surface, the block is accelerating downwards. I'm going to take downwards positive as well. So if I use F net equals MA for my block, it's going to be FG minus T4 is equal to MA, and M's value here is 50 times A. So I've already calculated FG. I'm going to take it to the other side now. I know that it's 490 Newton minus T4 equals 50A. And if I take the 490 to the other side, T4 negative is going to be equal to 50A minus 490. And what I need to go and do now is I need to go and take all 5 these equations and go and write them down one under the next. So my first one, T1 equals A plus 5. My second one, T2 minus T1 equals 2A plus 5. Then for my third one, T3 minus T2 equals 3A plus 5. And the fourth one, T4 minus T3 equals 5A plus 5. And my last one is negative T4 equals 50A minus 490. Let me just double check. Yes. Okay, now what I need to do is I need to go and solve this. So T1 minus T1 gives me 0. T2 minus T2, 0. T3 minus T3, 0. T4 minus T4, 0. So if you go and calculate on the left-hand side, we actually just have 0. This is going to be equal to A plus 2A, that's 3A, plus 3A, that's 6A, plus 5A is 11A, plus 50A is 61A. And then minus 490 plus 5 plus 5 plus 5 plus 5 basically means negative 490 plus 20 gives me negative 470. So what I'm going to do is I'm going to take the 470 to the other side, and I'm going to then change the sign, and then on both sides I'm going to divide by 61. So this is going to give me 470 divided by 61, 7,70. My acceleration is going to be 7,70 meters per square second. And if you go and have a look at our question, the direction for the acceleration is going to be clockwise, because these blocks accelerate to the right and this one downwards, and then we look at the direction of the pulley, which means that our direction here will be clockwise.